Welcome to the Calculus B section. In this section we'll be discussing work, the final application of integrals. We'll be looking at the amount of work done by force. So for all my physics lovers, we will not be discussing the work done by gases or work done on a gas. We will be discussing the amount of work that is done by a force over a distance. Given the formula, work is equal to force times change in x, or work is equal to force times the distance, we can have the formula work is equal to the integral of our force function from a to b with respect to x. So we can say that if a guy is pushing a block over a distance, and we can monitor that distance a, and let's say he finishes pushing that block to here b, we want to calculate the work done in between this interval. So what we do is we would say that f of x from b to a would equal f b minus a, and that looks an awful lot like f is equal to the change in x, or the change in distance, which would mean that work is equal to f change in x, or work is equal to f distance, which is also defined in physics above. Now, we generally use this for the energy dissipated, or the amount of energy required. So let's say we had a spring that naturally stretches to 40 centimeters, and we wanted to place a weight on the bottom so that a 30 Newton weight, actually, to stretch it from 40 centimeters to, we'll say, about 50 centimeters. And if we wanted to do that, we would want to find the force required to move it from 40 to 50. So every a 30 Newton force is required to stretch it from 50 to 40, but we want to see what the work is done on the spring. So in order to do this, we find the distance from its natural length, which is 50 minus 40, is equal to 10. Now 10 is equal to change in x, or the stretch, so that is equal to 10 centimeters. And we know that 40 newtons is the amount of energy that is required, and we know that our stretch is equal to 0.10 meters, which is 10 centimeters, times times k. So our f of x is equal to kx. That's just Hooke's law. So our function f of x is 40 newtons, our k is not known, and our x, our stretch, is 0.10 meters. So that means that k is equal to 400 newtons over meters, or equal to 400 joules, which means that f of x is equal to 400 joules, because that's going to be our actual force. So what we're going to do is that is the work done on the spring. And that's it. That's all we have to do. I hope that helps, and if you need more assistance, there's a bunch on the website.